Right, 5.6, you can use a given substitution to transform a second order differential equation into one of the above types of equation which you can then solve. Okay, so this is how it will generally come. It will generally be given the substitution to make, and then we're away. Now this is just breaking it down, this question, because the question really would be C, transform that using x equals e to the u. Okay, but here we go, we're breaking it down. So part A, it says show that x dy by dx is equal to dy by du. Okay, so all I'm going to do is write down what I'm being given, the substitution, x equals e to the u, and I'm going to differentiate with respect to that. Right, differentiate with respect to y. Okay, differentiate with respect to y, so I'm going to put that there. As you can see, the variable that we haven't got is y. So diff with respect to y, and you end up with dx by dy is equal to e to the u times by du by dy. Okay, I'm then going to reciprocalize this, and we end up with dy by dx is equal to 1 over e to the u dy by du. Now I'm going to bring this up, and it becomes eu dy by dx, and eu in the substitution, I suppose it's to show that, so I ought to show each step. So eu dy by dx is equal to dy by du, and obviously e to the u is x, so therefore x dy by dx is equal to dy by du. Okay, right, so that's the first bit done. Now it gets a bit harder, and we've got to use a chain rule here. Okay, it says you've now got to show that we've got this format, by the way. Okay, and you've got to show that d2y by dx squared is this palaver here. Now this is where it gets a little bit awkward, but it's not. I'm going to show you how to use a chain rule, and this is how we do it. Okay, so you get it in this like this, ready to go, and we're going to differentiate with respect to x. We're looking at this, and we're looking at this second order just here, and I'm going to say differentiate with respect to x. So we've got this, I'm going to write it down. X dy by dx is equal to dy by du. Now I'm going to differentiate this with respect to x. Okay, so it's a product. Differentiate the first, leave the second. Dy by dx plus leave the first x, differentiate the second. d2y by dx squared is equal to, and we are going to try and differentiate dy by du with respect to x. Now we can't do that, so how we deal with it is the chain rule. We are actually going to choose to differentiate it by what we can differentiate it by, which is obviously du. So we're going to differentiate dy by du with respect to u. That doesn't make sense. So to undo that, we're then going to times it by du by dx. So it's a chain ruling coming into play, because these cancel out and it means the same thing with differentiating with respect to x. So what it boils down to is, I'll do the next step, dy by dx on the left hand side plus x d2y by dx squared is equal to, and we're now going to do this. If you differentiate dy by du with respect to u, you get d2y by du squared, and we're timesing it by, so dot du by dx. Right, now we're going to make a substitution, because we know that dy by dx is replaced with 1 over x dy by du. So I'm now going to rewrite that there as dy by dx is the substitution there. 1 over x dy by du plus x x d2y by dx squared is equal to, and we've got d2y by du squared, and we're now going to find this here. Now to find that there, and this is the beauty of this method, you need a function for you in terms of x, and here is the function. So we're now going to differentiate that with respect to x. So you end up with, therefore, you end up with 1 is equal to EU du by dx, and therefore you can clearly see that du by dx is equal to 1 over e to the u, and you know e to the u is x, so it is equal to 1 over x. So where I see that now, I'm going to put 1 over x. And then finally, I'm going to times through by x, and we get, and throw that onto the other side. I've written that down, haven't I? I should have written that down. That was a substitution. So I've made the substitution dy by dx to this stage here. I was trying to make it that there, sorry, so it should be written already. Oh, I did, yeah, there it is. Gone lower. Right, sorry, throw that over, times through by x, so you end up with x squared d2y by dx squared is equal to, times through by x is d2y by du squared, and throw that over and times through by x, so it's minus dy by du, and that is the process. Now the hard thing amongst there is, how did we start? How did we start this whole process? Well, you started this whole process here. The very first step is a critical one. You've got y's mentioned, okay, and you're making this substitution. There's no mention of y in the substitution, so the clue there is to differentiate the y and then click it over. That's how you get your y involved. Secondly is the chain rule, to understand how you deal with differentiating. This bit here should ring alarm bells. You're trying to differentiate a differential, a first order differential, with respect to a different variable. It can't be done, so that's why we use the chain rule. You just differentiate with what you want and just undo it by timesing it by the du by dx. Okay, right, so that deals with that, and that's and then you always refer to the original thing, and you always have to get rid of this attachment by differentiating that with respect to x, and then you're away. Okay, right, then it moves on to part C, which says hence find the general solution of the general equation, this. So x squared d2y by dx squared can now be replaced with that. So I've now got d2y, so d2y by du squared minus dy by du, and plus x dy by dx. So you can see here plus x dy by dx is equal to dy by du. So plus dy by du and plus y, okay, and we've got plus y, and I think it equals 0. It's a homogeneous, yeah, homogeneous equation, so 0. Right, you can see the middle bits disappear, so therefore the using that substitution has transformed this to an easier, doable second order differential equation. d2y by du squared plus y is equal to 0. Now it's a homogeneous equation, so we don't need a particular integral. We're just going to go straight to the complementary function, and we're going to and bear in mind you've got y's and u's now, so think about how they fit in. The substitution you're going to make is y is equal to a e to the mu. Okay, that's why it's important towards what it's going to understand what the format is you're looking at. Okay. The auxiliary equation we can jump straight to. Augs eq will be m squared plus 1 is equal to 0, so it's complex. You end up with m is equal to plus or minus I. Okay, and that brings us to, and are you happy with me going straight to the answer on that one now? That's going to get the general solution. The GS will be y is equal to a cos u plus, and it is b sine u. Okay, and that's the answer there. Okay, right, so that's that one done. There's no boundary conditions. Right, brings us to the exercise. Okay, enjoy.